Hello, Dr. Cisse covering anatomy and physiology. Today we'll talk about the somatic reflexes. What is a reflex? What is a somatic reflex? How many types of reflexes do we know? How do we define a reflex arc? How does it happen? So let's talk about what is the reflex. A quick involuntary response. Why quick? You don't have to think about it. Why involuntary? You don't make a decision to do it. And then why you think that reflex happens? Because it had a stimulus. Something has to make it happen. At the same time, it's stereotyped. It means that a specific type of stimulus will produce a specific type of response. In this lecture, we'll be covering only somatic reflexes. Think about it. We have a visceral reflex and somatic reflex. When you see something you want to eat, something smells, a good food that smells so good, you will salivate. That's going to be a visceral reflex, right? Because it's going to be from your viscera. It's going to be something that is not your skeletal muscle. But somatic reflex only involve skeletal muscles, voluntary muscle that we can control if we want to. So if it's a somatic reflex, it is the movement of your skeletal muscle without your control. But normally you can control it if you want to, if it's not a reflex. But if you take a visceral reflex, for example, your saliva, you don't make a decision to secrete your saliva, or you don't make a decision to produce tears. They just come out of the glands, right? So those are going to be visceral reflex. Today we'll talk about only somatic reflex. The knee-jerk reflex is one example. When you go to the doctor, you always get this done. The doctor come and tap your knee, you jerk. So we're going to explain this process. Here you see the spinal cord, you see the gray matter, you see the white matter, you see the sensory nerve coming in, the motor one coming out. So we'll talk about this in detail. So what is the pathway of the somatic reflex? First, a somatic receptor on the skin, muscle, or tendon has to receive the stimulus. Then an afferent or afferent nerve fiber has to take that stimulus, has to conduct an action potential along that nerve fiber to go into the spinal cord. Inside the spinal cord, that information has to be processed. Sometimes it could be just one neuron talk to the next one. Sometimes it could be more neurons involved talking and making decisions, depending how urgent it is. Then a motor neuron has to take that command from the interneuron to work on the effector organ so that the reflex can be completed. And that effector organ has to process the command. So in our muscle, we have stretch reflex. We do stretch reflex. What is the stretch reflex? When a muscle is stretched, it fight back and contract if it's gonna go over your anatomical position. So there's a limit to what you can do with your muscle. Why? Because you have specific receptors that protect you from going over your anatomical position. It has to stabilize your joint. When you're walking, as soon as you go off a little bit, it hurts you, you come back. Why? Because you have stretch receptors that have a limit to how much you can stretch those muscles or those joints. So it is usually mediated by your brain. But a spinal component can be more pronounced if muscles is suddenly stretched by a tendon tap, for example, knee jerk. It means that you can do that with your brain, but sometimes if it's so quick, it doesn't get to your brain, stops at your spinal cord. What is the flexor reflex or withdrawal reflex? How come when you touch something hot, you move your hand without thinking? Because what your muscles receptors receive a heat, right? This is a stimulus that will excite the neuron to your spinal cord to come back to your muscle to get away from the danger. Why? It's an emergency case. The hot part is so hot it can hurt you. It is done for you without your thinking, without your brain involvement, because it is something that needs to protect your life. Let's talk about patellar reflex. In patellar reflex, I'll introduce reciprocal inhibition. We talk about this in class. So usually when you have one muscle doing something, like an agonist, if there's an antagonist muscle, a muscle that goes against that muscle will be inhibited so that you won't pull against the muscle that needs to do the job. So we'll talk about this now. Look at this one, for example. You see in the knee jerk test, you have a tapping material tapping the knee. Then that receptor is excited and an action potential is generated that will run through an ascending afferent sensory neuron to the spinal cord. That sensory neuron is a unipolar neuron that will take the information to the spinal cord. In the spinal cord, the sensory neuron with synapse will connect with the second neuron. That could be one neuron that will be a motor neuron that will go into the muscle that need to be flexed, that need to be stretched. And it can also synapse, maybe connecting to an intraneuron that will talk to a motor neuron that will innervate the muscle, the antagonist muscle, so that antagonist muscle can be inhibited, so that it will not stop this quadricep muscle from stretching. So not only you are flexing one muscle, but you are stopping the opposite muscle, the antagonist muscle, to contract. So you kind of relax this muscle, 7, and then contract this muscle at the same time so they won't go against each other. So because this one is inhibited, right? So this one is inhibited, this one is excited. So we have two different actions on the same thing. So that's why it's called reciprocal inhibition. And then the flexor and cross extension reflex. It means that if you step on a nail, for example, you have to remove the foot that's on the nail off the nail very quick. In order for you to do that, you have to have your other leg being contracted so you can stand on it. So the stimulation of your right leg actually goes through your sensory neuron to your spinal cord and cross over basically to the other side, to the other leg, so that it can excite the other leg so that you can stand on it. That is called cross extension reflex. So let's talk about the type of reflex in general. Cross extension reflex, we got that. Contraction of extensor muscle in the limb opposite of the one that is withdrawn, right? So it kind of maintain your balance. Flexor reflex, use an ipsilateral reflex on the same side. It means that the stimulus and response are on the same side. Whereas cross extension reflex uses a contralateral reflex arc. You have to cross over. And their intersegmental reflex means that sometimes a pain in the foot, for example, in one part, can cause contraction from another part of your body. That's not even the other side, but completely. Foot causes contraction of abdominal muscle. When your foot hurts, you kind of contract your abdominal muscle. They're intersegmental because it's not even the same section of your spinal cord. The tendon reflex, inside our tendon or muscle, we have proprioceptor. Those are receptors that allow you to know where you are, what your body part is. So proprioception will be, for example, if I'm putting my hand behind my head, in my head, I can tell where is my finger in my head. I don't see it, but I can kind of tell. That's called proprioception. So the tendon reflex is very important because it has to be there so that you will not go over your anatomical position. It's protection. So the tendon organ will have tendon reflex. To conclude, we have somatic reflex. Now we know what is the reflex. Quick response. Somatic reflex. Why somatic? Because it affects your skeletal muscle. The flexor, you're touching hot water, you move your hand, hot pot, you move a hand, you flex your hand very quick. Stretch, when you stretch too much, it hurts. You come back to yourself. Knee jerk, when you get to the doctor, you stretch because it goes back to your spinal cord to excite the muscle, the quadricep muscle. Cross extensor reflex, when you step on the nail, the other leg will be stretched. And the reciprocal inhibition, every time you stretch one muscle, the antagonist muscle will be relaxed, will be inhibited. All right, I hope this is going to be very, very helpful, and I'll see you in class. Thank you very much for watching. Bye-bye.